Episode 4. Getting functional. Functions are what make up the bulk of any program. When we build a processing program, both the setup and draw sections of the code are functions. These just happen to be required by the program to function. These just happen to be required by processing to operate. However, using the processing reference, there are a plethora of built-in and predefined functions that we can use. For example, void mouse press with a capital P is a function that is called anytime the mouse is pressed on a processing sketch, for example. If I run a processing sketch and click in it, you will see that pressed appears in the console anytime I push the mouse. There are one for key press. We can do one to identify specific keystrokes, but we can also write our own to do very specific things as and when we want them. We can also do these to completely change the way that we use the void draw section. For example, rather than having lines and lines of code in void draw that clutter up, you can use void draw to call a variety of functions one after the other that then handle and deal with all the variables and handling of data that we need without having to have it all cluttered within the draw section. One example would be the changing of a variable. For example, if we do int x is equal to 0, in void draw, let's add a line that prints the value of x on a new line every single time it runs. As x is a global variable, it means that it can be accessed from anywhere, which for now will keep functions simple. So as we can see, 0 was printed on repeat. But now, what happens if we added an x equals an x++ function? So we're going to increase the value of x by 1 every single time this program runs. We can see that x keeps incrementing and incrementing. We can add this into a function. To do that, similar to the way that draw and setup work, we create a new one, void x addition. While not necessary, it's common practice to capitalize the first letters of additional words and functions after the initial word. So for example, if our name was add x to current number, it would be common practice to capitalize the n of number, the c of current, the t vo, and the x of x, while leaving the a of add lowercase. And the exact same way that void setup, our ifs are for whatever functions we're using, the function is defined within the curly brace. So now I can move the x++ to here, remove this one, and all we need to do is, instead of telling draw to reference ++ here, we need to tell it to go and run this x addition function. And to do that, we simply type the name of the function followed by a semicolon. So whereas a curly brace defines code of a function, we know that a semicolon defines an action of a program. Now if I run the code, we will see that x increments the exact same way. And that is simply because void draw is being called, it's seeing that x addition needs to be run, it goes to x addition, runs all the code in here between the curly brace, so 14, 15 and 16, then returns to line 9 and continues on from there. An example of this, using our spreadsheeting tool or our flowcharting tool, is visible. So our program runs. It reaches our command to call the function, which it then runs the function code, returns the updated variables, and then continues with the main program. In this case, the value of x comes in, it's added to 1, and then it leaves again. Obviously, this is a very simplistic example, but we can do much more complicated things with it. Almost any piece of code can be added to a function for matters of simplicity. Functions are great to keep a library of, in the way that we're keeping a reference, as that you can cut and paste these wherever you need. Before you can do that though, it's always good practice to take them from being globally scoped to locally scoped, and to do that, we need to change the way that it's written. So instead of dealing solely with global variables, it can be untidy and really confusing in larger programs. To solve this and make your functions more portable and adaptable, we turn these into locally based variables. And to do that, instead of having x as something that's accessible up here, we turn it into something that we pass into addition and then receive back out again. To do this, we remove the use of the void command and change it into a returned variable. In this case, addition is going to return an integer for us. The first thing we're going to do is we're going to tell addition that we're passing a value of x instead of just simply accessing it globally. To do this, we pass it x, and then come down to addition and tell it that it's going to receive an integer titled x. In this case, I'm going to change its name as we'll only use it once. And then I'm going to set a new local variable called in is equal to xin. So what we're saying is that we have a variable equal to 0. We're passing it into x addition that is then reading that variable, turning it into a local based one, and then we are going to do in plus plus. What that simply means is take whatever number comes in, turn it local, and then add 1 to it. And then we're going to do what's called returning in. And instead of void, our function is now going to return an integer. To capture this, we need to define a new one. Let's call it y. And y is going to be equal to y plus x addition. So now, when we run this, all things going smoothly, we should see the same result, but it's all happening in a non-destructive way. So you know that you could save x addition as a separate function and copy and paste it anywhere you need to add a number. All you need to do is make sure that you pass the correct variable into it. That is how variables work in their most basic and a slightly more advanced version where you're both receiving values back from it. Functions can be used for anything from adding a number to validating whether something's true or false, as we will do slightly later with our box test. For now, I'm going to load up our reference patch and add this addition. So what I'm going to do is I'm going to offload all of our loops externally. So I'm going to copy all of the loops and create a new function called loops. And add this to our optional functions section. So now, pushing play, nothing will change. Our reference will still work in the exact same way, where it will list our if statement, our for statement, and then our while statement. But it's all doing it without draw being cluttered at all. It's gone from being something that was 20 lines of code to simply 3. This is the power of functions and how to use them in your day-to-day programming. Use it to make things neater and also make things more modular so that you can both copy and reuse your code as and when you need it. So if you find that you're constantly reusing a function or a mathematical calculation, say multiplying numbers together or checking whether two numbers are the same, add these into a function and then you'll find that your workflow increases. Saving our reference, the final thing we need to do is add functions to our program. This is where it's going to get a bit more complicated. We're going to use a function to check whether our box is outside And if it is, we're going to change, instead of just returning x to its starting position, we're going to bounce the box back. To do this, instead of checking whether the x position is inside or outside, we're going to get a function to do that. First thing we need is two booleans, one called xdir for x direction, and then called ydir naturally for the y direction. We're going to create a new function called check bounds, and down below in the functions we're going to add void check bounds. So the first thing check bounds is going to do is we're going to reuse this and change the way that we check whether x is in or out. So if our x position is greater or equal to the width of our sketch, we're going to make something happen. So if x position is greater than the width, we're going to say that xdir is equal to false. Otherwise, we're going to say xdir is equal to true. We're also going to add a second conditional if here, that if it goes too far the other way, we're going to say else if x plus is less than or equal to 0, xdir is equal to true. Now what does that mean? That means that when our box is too far to the right, we'll get a false message, and when it's too far to the left, we'll get a true message. Now what we need to do is change our movement information here so that it reflects properly, whereas if it's false, it's going plus, and if it's minus, it's going the other way. So I'm going to add a new message called move box, or a new function, excuse me. Move box's job is purely going to be update the x and y position of our box. So if, and a quick shortcut here for validating a boolean, so if xdir, that simply means is if x direction is true, if x direction is true, xpos is equal to xpos plus movement. Else xpos is equal to xpos minus movement. So what does this say? This says that if x direction is true, e.g. it's too far left, then we're going to add to our current position. Otherwise, if it's false, so too far to the left, to the right, we're going to minus from it, hopefully creating a bouncing scenario here. Let's test it. So you can see it goes along and it bounces back. So now we know that both of our functions are working properly. All we need to do is add an additional one for the y movement, and then we'll be there. Simplest way, I'm going to copy both of our existing and change the x for a y. So now hopefully we should see the same. while it looks like it's just the same but on a diagonal, we now have two functions running simultaneously, checking both the horizontal and vertical movement of our object. To make this a bit more exciting and a bit more dynamic, we're going to add a final function using one of the inbuilt processing functions, mouse pressed. What we're going to do is every time we push the mouse, we're going to randomize the location of our box. So x position is equal to int random width, and then y pos is going to be equal to int random height. So now, when we run our sketch, when we push the mouse, it will randomly move our box within our display. Now you can see, with what's only taken maybe an hour and a half's worth of development, we've created a fun and semi-interactive game already. This reminds me very much of Solitaire from Windows 98, if any of you remember that. In the next episode, we're going to look at how to make this more interactive and change occurrences within this sketch depending on where we click and how we click.